Paradoxes. What are they and how do you solve them? Now, by paradox, I mean a statement that is self-contradictory even though it's based on a valid deduction from acceptable premises or, in perhaps more ordinary language, a conflict between necessary conditions. Now, the example I'm going to use is one of Zeno's paradoxes. This one involves shooting an arrow at a target. The arrow has to pass through a distance d before it can hit the target. But first it has to pass through the halfway point, and the halfway point of the halfway point, and the halfway point of the halfway point of the halfway point. You get the idea. It is a fact that the arrow has to travel through the halfway point. And to be clear, it is also a fact that the arrow does hit the target. Let's not get too metaphysical here. We're looking for a useful theory, which means it has to follow what we observe. In this case, that means theory says the arrow reaches the target, because that is what we see actually happens. At the same time, the theory should be limited to what is actually possible, otherwise we'd just say everything is magic. But it seems that the theory says the arrow never reaches the target. Well, why? Let's be clear on what we are assuming here. We assume the arrow actually hits the target. We also assume that it is impossible for the arrow to cover an infinite number of finite distances in a finite amount of time. No matter how small the distance, says the logic, there is always a halfway point between start and end, so distance can be divided an infinite number of times. I won't do the math here, but let's just say an infinite sequence shouldn't be completed in a finite amount of time. Hence we have the paradox, two conclusions that contradict. The arrow reaches the target, the arrow never reaches the target. Now, the way to solve this is to challenge the assumptions. Zeno argued that the assumption of infinite division must be wrong, so that yields one of two solutions. First, we claim that there really is such a thing as a smallest unit of distance. Now, for those of you who are interested, it is Planck length, named after the physicist Max Planck, 1.6 times 10 to the minus 35 meters approximately. Now, if that were visible to us, if we were small enough to see that sort of distance, then a proton would be about the size of Jupiter. So it is really small. The second solution suggests that time is not infinitely divisible, but actually the two ideas are sort of connected. There's this thing called Planck time, which is how long light takes to travel 1 unit of Planck length. So, just so you know. The point being, if we challenge the underlying assumption that something can be infinitely divisible, then we conclude, as Zeno did, that nature must be atomic. That is, it is made up of discrete chunks of stuff that can't be further divided. And that means that our paradox goes away. We can limit our theory to what is possible, and the arrow still gets to hit the target. In summary, I believe paradoxes don't exist in reality. If you hit a contradiction in reasoning, like a paradox, look for a flaw in your reasoning. And the flaw is almost always in the assumptions. Thanks for watching, and remember, check your assumptions.